because you already know this stuff. This is not anything big. How many zeros is the first function going to have? 3. How do you know? Third power. It's going to have 3 zeros. Absolutely. Okay. How many zeros is the second one going to have? 4. It's the quartic. It's going to have four zeros. Okay. So 3 zeros for this one, 4 zeros for this one. We don't know for sure what kind of zeros. They may repeat, have a multiplicity of 2 or 3. They may be imaginary. They may be real, rational ones. But we know there's 3 zeros and 4 zeros. Make sense? Okay? So nothing new there. This is a little bit new, and it can help us find out which zeros we should be looking for. There was a gentleman by the name of Rene Descartes, and he worked with this stuff. And he found out that if he looked at, did enough of these, he would find a pattern. Okay? Turns out that if you want to know how many positive zeros you have, just like we can say factors of the constant over factors of a leading coefficient will limit how many zeros we have, this also helps us decide whether or not to even bother to look at the negatives or the positives. Because he found out that if you count how many sign changes there are, that you will know how many positive zeros there could potentially be. Okay? So this is a positive 2x to the 6th, right? Negative 5x to the 5th. Did we change signs? From this term to this term. This one was positive. This one's negative. Is that a sign change? Yeah. So we've got one sign change here. Okay? This one's negative. This one's negative. Is that a sign change? Nope. Stayed the same. Okay? How about negative 3x to the 4th to positive 3x cubed? Yes, there's a sign change. What about positive 3x cubed to positive 10x squared? Is that a sign change? Nope. How about positive 10x squared to a positive 1x? Nope. How about positive 1x to a negative 9? Yes. So how many sign changes did we have altogether? 3. So we have a possibility of 3 positive zeros. But there's a kicker here. Equal the number of sign changes or less than this by an even number. So we can take away 2 of them and have 1 positive 0. And why is that? Because our imaginary numbers always come in pairs. So if we have a positive I for a 0, we're going to have a negative I for a 0. That takes away 2 possibilities and leaves us with just 1 positive 0. So we know we're going to have at least 1 positive 0. Yes? Mm-hmm. So if it was 5, if we had 5 sign changes, then we could have 3, 5, 3, or 1 positive zeros. Always by an even number. Always take away 2 from your, yep, always 2. Yep. Nope, because the imaginary numbers always have to come in pairs. So if they're taking up a 0, they're going to actually take up 2 zeros. And it's always going to decrease by 2. Okay? All right. So he also figured out that he could figure out how many negative ones there were going to be. And this was not quite as simple, but it's not bad. He said, let's put in a negative x in place of x instead. Everywhere I see x, put in a negative x and see how that impacts the signs. So when we take an x, negative x, and we raise it to the 6th power, is it going to be positive or negative? We take a negative times 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 a negative, even times. Is it positive or negative? Positive. Yep. Anytime you raise a number, a negative number, to a positive power, it takes it times itself an even number of times. It's always going to be positive. Okay? So what he said was he took these same things, 2x to the 6th, but now it's 2 times negative x to the 6th. Well, that's going to be positive, because that 6th power is going to make that negative a positive. Negative x to the 5th is going to be negative, but there's a negative 5 waiting out in front, so this will be positive. Negative 5 times a negative x to the 5th is going to be positive. Okay? What about negative 3 times a negative x to the 4th? Negative x to the 4th will be even power, so this part's positive, right? It's got a negative 3 out in front, so that's going to be negative. What about a negative x to the 3rd? The 4 is even, so this part's going to be positive, but it's got a negative 3 in front, so that's going to make it negative. Thank you. Okay? Right? Okay? It doesn't, the power isn't to over the negative 3, the coefficient, so the coefficient is boss. Helps to decide what it's going to be. Okay? How about this one? Negative x to the 3rd. This part's going to be negative, and it's going to be taken times a positive 3, so negative result. Okay? What about negative x squared? Negative x squared will be positive, but what's waiting out in front of it? Positive, so positive times positive, positive. What about negative x to the 1st? Negative, and there's a positive 1 times it, so that's negative. What about negative 9? Negative. So here are my sign changes. Positive to positive, do we change the sign? Nope. Positive to negative, do we change the sign? Yes. Negative to negative, do we change the sign? Nope. Negative to positive, do we change the sign? Yes. Positive to negative, do we change the sign? And how about negative to negative? Nope. So we have a total of 1, 2, 3 sign changes again. So since there are 3 sign changes, we have a possibility of 3 negative zeros. But because of those imaginary numbers that can come along with them in pairs, it's 3 negative, or how many negative? Just 1. Okay. So we could have a total of 3 positive. We know we have 6, right? 6 zeros. Okay. We could have a total of 3 positive real zeros and 3 negative real zeros and no imaginary, for a total of 6 zeros. Okay? Or maybe we only have 2, or sorry, 1 positive real zero and still 3 negative real zeros and 2 imaginaries. And we still would have 6 zeros, right? Okay? Always going to have 6 zeros no matter what. We just don't know what combinations they are. Maybe we have 3 positives and 1 negative and 2 imaginary. Or maybe we have 1 positive, 1 negative, and 4 imaginaries. Those are possibilities. Am I going to ask you to make the table each time? No. But I want you to understand that those imaginary ones always travel in pairs, and they're going to influence how many positive zeros you can have and how many negative zeros you can have. Okay? Yep, because it will help you. There may be times when there are no positive zeros, so you don't even bother to try them. Or there are no negative zeros, so you don't even bother to try them. Does that make sense? Helps you work more efficiently. So yes, I will ask you to use Descartes' rule of signs. That way you're not continually trying and wasting a lot of paper using synthetic division on things that aren't even going to work. Okay? All right, so next example. So let's figure out, first of all, how many zeros there are, and then whether they can be, what kinds of zeros they could be. So first one, how many zeros? 3. 3 zeros. How many zeros for the second one? 4. 4 tick. Okay. Let's look at our sign changes. The first one's positive, right? Positive to the second one. Is there a sign change? Yes. How about to the next one? No. So how many positive zeros can we have? 1. So we know to look for a positive 0. Okay? We have 1 positive 0. What are our options? What are the possible zeros that we could have? Kayla, what are factors of 4? What numbers multiply to get 4? 1 and 2 and 4, right? So it could be a 1, it could be a 2, or it could be a 4. One of them is going to work. So out of the millions, billions, infinite number of possibilities out there, we've said, hey, guess what? We know one of our answers is going to be either 1, 2, or 4. Because we know we have a positive 0. Does that make sense to everybody? It just made your life a lot easier. Once we find a positive 0, we know that we aren't going to have any more positive zeros because Descartes' rule of signs says only 1. Let's see about negatives. Okay? Negative zeros. If I put negative x in here, cube it, minus 6 times a negative x, minus 4, what's the net result of this? Negative 6x cubed, is it positive or negative? Negative. If I take a negative 6 times a negative 1, positive, and negative 4, is there a sign change here? Yes. Is there a sign change here? Yes. So what does that tell me? 2 negative zeros. Okay? Or I could have always decreased by 2. Doesn't make sense to decrease 1 by 2, right? We can't have a negative number of zeros. But we could also have 0 negative zeros. So knowing that, I'm going to focus on the positive ones first and see if I can find one of those zeros. Make sense? So let's do that. Writing our coefficients out, we have to make sure that we hold the place for what? X squared, because there is no x squared. So we've got a 1 for x cubed, no x squareds, negative 6x's, and negative 4. Which zero do we want to try first? 2. Trying 2. So when we take our 1 down, 2 times 1 is 2. 2 plus 0, 2. Careful not to times it. I wanted to times it in my head. 2 times 2, 4. We're multiplying down here. In the middle, we're adding. Negative 6 and 4. negative 2. 2 times negative 2, negative 4. Did we get a 0? Nope. Don't get to put a happy face in there. So 2 didn't work. What do we want to try next? Got a 50-50 shot. Who wants to pick it? 1. Let's try 1 next. Put the 1 out in front. Same numbers. 1, 0, negative 6, negative 4. Drop the 1. 1 times 1. 1 plus 0. 1 times 1. Negative 6 and 1. Negative 1 times negative 5. Are we getting a 0? Nope, sad face. Okay. 1 didn't work. So our only other option's 4, right? Let's try 4, otherwise we made a mistake somewhere. Put a 4 out in front. We have a 1, 0, negative 6, 4. Drop the 1. 1 times 4. 0 and 4. 4 times 4. Ooh, we did something wrong somewhere because one of those should have worked. You see that negative 6? We're going to get a negative 10 here, or positive 10 here, and 40 is way too big. So what did we do wrong? Dropped our 1. 2 times 1 is 2. 2. 4. Negative 2. Negative 4. Negative 8. Didn't work. Try our 1. 1. 1 times 1 is 1. 1. 1. Negative 5. One of those should have worked. Where did we make our mistake? We didn't need 2 zeros there, did we? Descartes' rule of signs. Positive to negative should have been 1. So it could be an imaginary one. Let's try our negative numbers. Okay. 2 was so close, wasn't it? Let's try negative 2. Okay. 1, 0, negative 6, negative 4. Drop the 1. Negative 2. Negative 2. Positive 4. Negative 2. Positive 4. There's our happy face. We got a 0. Okay? So we have some kind of complex numbers here that took away one of our positive zeros. Okay, so here we go. Depressed equation now, right? Everybody agree? It's not x cubed anymore. Now it's x squared. Can we factor that? Did a t-chart? We have factors of 2 that can, negative 2 that add to get negative 2? Nope. So what are our options? Anybody want to complete the square? Or do you want to use quadratic formula? See how we're reviewing for our final as we do this stuff? Because these were things that we've done in the past. And we repeat and review so that you can learn and be ready. Okay? So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay? So negative 2 squared is going to be 4. We always do what's in the quadratic first. Negative 4 times 1 is negative 4, times negative 2 is a positive 8. 4 plus 8? 12. Is there a perfect square in 12? 4. That 4 comes out as a 2. The 3 stays in. 2 on the bottom. Everybody's got a 2. So we'll have 1 plus or minus the square root of 3. Negative 2 was a 0, and 1 plus or minus the square root of 3. See how the 1 plus the square root of 3 took away one of our positive zeros? The 1 minus the square root of 3 took away one of our negative zeros, and the negative 2 was our other negative 0. Everybody cool with this? A lot of work, isn't it? I won't give you tons of these. Okay? That's not the goal. It's to understand, use their whole culmination of everything that we've learned to be comfortable, familiar, and faster with these kinds of things. I want to work the next one together? Yes? Okay, you don't have a lot of space in your little box to do those. Okay? So you might want to have another sheet of paper out. In fact, I'm going to go back too, because this was the same problem that we had right here. So you told me 4 zeros here. Okay? Let's look at Descartes' rule of signs to see if it will help us. Positive to negative. Did we change the sign? Yes. How about from negative to negative? Nope. Negative to positive. And positive to negative. So how many positive zeros could we have? 1 or 3. Okay. How about negatives? If we put a negative x in here, a negative x to an even power is going to be positive. A negative x to the odd power times a negative. Negative x to an even power, positive, right? Times a negative. Does everyone understand how I'm doing that? Do I need to write it out? Guys okay? Or do I need to write it out? Okay. Negative x times a positive 11. And then a negative 6. How many sign changes did we have? Just the one, right? So we know that we have how many negative zeros? Okay. 5 terms there. Can we group? Nope. What are our possible zeros? We know we have 1 or 3 positive zeros, 1 negative zeros. What are our options? Viviana, what are our factors of negative 6? Or just plain old 6? What numbers multiply to get 6? 1, 2, 3, and 6. And we're good. Okay? Remember, those could be positive or negative, so you can write them out separately if you want to be able to mark them off. So 1, 2, 3, and 6, or -1, -2, -3, and -6 are our options. And then you want to try some things and see if you get lucky. Okay. So, am I missing any? Do I have any holes here? Nope. So we get to write all of our coefficients out. We have a 1, a -3, a -3, an 11, and a -6. What do we want to try first? 3. Okay. So we're going to try a +3. We drop the 1 down. And 3 times 1? 3. -3 and 3? 0. 3 times 0. -3 and 0. 3 times -3. -9 and 11. 2. 3 times 2. Woohoo! Happy face. Party time. Room 310. Okay. We've depressed our equation. I don't know that we can factor an x cubed minus 3x plus 2. So we have to keep going. Okay. It was an x to the 4th, so now we've got an x cubed, no x squareds, minus 3x plus 2. Can't factor that, so let's keep trying. All right, so we got one of our zeros. It was a +3. Okay. Looks like we'll probably have a negative for a 0. So anyone want to try a negative number? -2. All right. Dawson was right on the first one. We'll see if he's right on the second one. If he is, we'll take him to the casino and let him bet on some cards. All right, so 1 comes down, -2 times 1. And 0 and -2. -2 times -2. 4. -3 and 4. -2 times 1. And -2 and 2. Happy face. His luck is running strong. Okay, so we know 3 is one of our solutions, and -2 is one of our solutions. Yep, we use the new one. Keep making it smaller. Yep. Once you've depressed it, we know that 3 was a 0. We took it out. Now use the new one and continue to make it smaller. Because now we've depressed it again. What is this guy? It was a 4th power. This one's now a 3rd power. So this one's going to be x squared minus 2 plus 1. Can we factor that? We have factors of, sorry, yes, I'm sorry. Do we have factors of 1 that can add to become -2? Yeah, you guys should be shaking your head emphatically because we don't want to have to do this again. X and X, 1 and 1, and minus minus. So, summary, our zeros are -2, +3, and don't let the factors trip you up. What are the zeros here? 1 and 1. So you can write 1 with the multiplicity of 2, or you can list it again. I don't care how you give me the answer, as long as you recognize what multiplicity of 2 means, if it should show up on a multiple choice test or something. Those are our 4 zeros. Pretty neat, huh? We're not shooting in the dark anymore. We know something about Descartes' rule of signs and something about their leading coefficient and their constant factors. Therefore, we can do what we need to do. Okay. By the way, this is what this first one looks like, right? No surprise there. So we said we had zeros Where do we find them? Negative 2 and 1 plus the square root of 3 and 1 minus the square root of 3. So there's our negative 2. This one's between 1 and 0. This one's between 2 and 3. Okay? And here's our other one. Notice it just kissed the graph. Why did it just kiss the graph and turn around? Kiss the x-axis. Why did it just kiss that point? Multiplicity of 2, wasn't it? We had 1 as our answer twice. So it just went up and touched it and then did its dance. Okay? Makes it flirt with the graph. Just give it a kiss and then go continue dancing. Okay? I don't know. Something silly. Those things make you remember stuff, hopefully. Okay? So we'll come back and talk about this tomorrow. Okay? But I think that you can do numbers 1 and 3. So work on 1 and 3 on your sheet. And then we'll come back and talk about the rest tomorrow. Everybody come back with 1 and 3 done, please.